Hi, everybody. This is Andrew here. We are just getting started with our second. I'm just going to turn off this right here. Getting feedback from my audio. So, thanks again for joining us in our second installation. We have Westpower showing us some condition monitoring and essentially, what the movement is going towards new technology. So, anyways, we just had some difficulties with audio, and Jared's going to try and join us hopefully later on. So, anyways, looks like we have a lot of people here, primarily from Alberta, but we have some people from India again, and some people actually from Denmark. So, welcome. It's probably pretty late over there. Anyways, we heard some feedback from you guys, and some topics we were, seemed to be a common theme is turbines, compressors, recip as well. So we're going to try and get some content for you guys to for some different things. So now I'd just like to introduce Westpower. So Jared here is a business development for reliability products and services. I grew up in Regina, graduated from the University of Regina with a bachelor's degree in petroleum systems engineering. He played university football and basketball as well under a dual full athletic scholarship. So he's not just brains, guys. He began his career in Alberta working in the pump industry, repair, project management, field service coordination, inside application and sales engineer. And so he's a PEGA member. Now he's in a new role as business development for reliability products and services with Westpower. And he's also been involved with RATS for quite a while now, and became a board member as well. So he spends a lot of time playing, watching sports, biking, hiking, canoeing, and doing a bunch of home renovation projects and very interested investments. Adrian, he has a Ph.D. and so more brains in the team here. He's the technical lead for liability services. Grew up in Kingston, Jamaica. Graduated from University of West Indies, St. Augustine campus with a bachelor's degree in mechanical engineering. I did a master's at University of Manchester, maintenance engineering and asset management with distinction. And so he decided to go back. He didn't have enough, and he wanted to go back for a Ph.D. in mechanical engineering from University of Manchester as well. So his thesis was on bearing vibration response integration for condition monitoring of rotating machinery. So I think it's safe to say he knows what he's talking about. So I began a career as a reliability engineer in Jamaica with Alcoa Minerals, and afterwards had various different roles in the country. Technical consultant with ITT Goulds, and eventually he made his way to Canada with Westpower in 2018. So he's an APEGA member as well with his P.Eng status in Canada, and he has over 15 years of engineering experience. So he does have a lot of publications in academic journals, actually. So he's a car lover and sings tenor and church choir. And the next thing on the list, I guess, is learning bass guitar. So lots of interests. Anyways, we have a very talented team over there at Westpower. They know their stuff, and hopefully you'll learn something new today. And as always, we have our question function. If you want to ask questions, we'll answer them either during the meeting or during the presentation, or we can talk about those afterwards as well, just depending on the nature. Feel free to chat me during the presentation if you have any questions or issues or whatever, and I can handle those behind the scenes. So you'll also see that there's handouts on the side panel in your control panel. So you can download those at any time, and that'll give you some more information. So in the meantime, I'm going to just shut off my webcam. I'm going to let these gentlemen take the floor and go from there. So I'm going to hand over the presentation over to Adrian now.
Good afternoon.
You pulling up the first one there? Perfect. Okay, we good, Adrian?
Should be sharing now.
Yep, looks good.
Yep.
Okay, I'll just start with a quick intro before Adrian gets into the technical portion here. So first of all, thank you very much for everyone tuning in, taking your lunch hour and the time today to attend the second online RATS technical presentation of the series that we've been putting on here. I know everyone's probably getting a little tired looking at their computers and listening to webinars and all that. So we're gonna do our best to put some more engagement and interaction opportunities throughout the presentation today. So it's titled The Practical Who, What, Where, When, Why, and How of Industrial Internet of Things for Condition Monitoring and Machinery Health Management with a case study. We didn't get too cute with the title. It's pretty deliberate. What it means is what we're going to go through. Anything today you'd like some more info on, there's myself and Adrian's contact information. Feel free to give us, drop us a line or an email anytime. We are part of the, as Andrew mentioned, the Westpower reliability team that's been built and geared toward helping facility operators improve asset lifetimes, cost effectiveness, and overall performance. As Andrew also mentioned, we highly encourage the audience to download the informative PDFs located on the control panel. There's more of those. Should you desire more information, we can get that to you. We're going to post a video link as well that goes over in-depth Machine Century a little more for you guys, as well as there's their YouTube channel as well, which is always good for learning and all that good stuff. So we'll try our best throughout the presentation to look at the chat box and answer your questions as we go. Anything we can't get through, we're gonna make sure that at the end of the presentation we answer it. Worst case, if there's no time left, we will get back to you via email and make sure everyone's questions are answered and you get the info that you need there. So without further ado, we'll go to the second slide, please, Adrian. Okay, so before we go into it too much more, just a quick safety moment. It's very important, maybe even more so than ever. Things are starting to get back to somewhat normal. So, we're getting back into the home and work routines. Let's not forget all the measures that are put in place to help protect everyone at the office, on site, and on the road, because the main goal is let's get everyone home safe at the end of the day. So as we get back into our regular routines, let's not try to rush to make up for these last 4 months that we've been locked down. Let's do it smart. Let's be safe and be mindful. Okay, and for those of you who are not familiar with Westpower, just want to do a quick overview so you know who we are and what we do. We are Alberta owned and operated, and we have been providing pump solutions to a variety of markets for over 27 plus years. We've grown to over 170 plus engineers, CETs, millwrights, technicians, and a variety of subject matter experts from different backgrounds across Western Canada and spread over Western Canada throughout our 5 facilities in Calgary, Edmonton, and Grand Prairie, as well as our Salt Lake City, Utah facility, R&R Machine. We're always looking to expand our pump portfolio and our knowledge base to better serve multiple industries, which includes our exclusive partnership with ABT Machine Century, and it is one of the top tier platform asset management hardware software packages that is available on the market today. So we're going to use that to review the basics of the who, what, when of condition-based monitoring, and we are going to utilize our ABT Machine Century platform to demonstrate a successful case study to give you a better real-life look at how this stuff works and what it can actually do. So with that, I believe we have our first quick poll question here. If Andrew can get that up for the audience. And at this point, I'd like to hand it over to my colleague Adrian to take it away after we've done the poll and give you a good in-depth look at how all the industry 4.0 technology really works and gets put to use for some serious energy and cost savings. Thanks a lot, and should be good.
Okay, so as you can see, there's a poll open on your screen, so feel free to select, what best describes you. And actually, I left this open so you can answer multiple different ways. Well, very good. We've got a very good turnout of answers. I'm just going to leave it for a couple more seconds. Okay, so we'll shut off the voting in 5 seconds. Okay, thank you. Let's see here. Whoop. Looks like I jumped into the wrong thing here. So close, I believe. So I apologize. I need to, there we go. So it looks like 20% are identifying as end user site operations, 9% EPC consultant, 42% mostly are service providers on the call here, 29% OEMs, and 18% other. I'm not quite sure what other is, but I put that option in there because I figured, there's got to be something we didn't think of. So, if you want, you can send a chat directly. Just let me know, what other was. But I'll let these guys carry on with their presentation. So thank you for participating.
Okay, thank you, Andrew. Let me know if the screen share is coming through.
Yeah, it was.
Yep.
It is.
You can see you in slide number 4 there, Adrian.
All right. Good afternoon, everyone. So I'll get straight to it. I'm Adrian Nembhard. So Industry 4.0 and IoT, it's a buzz term it's terms that are going around. It pretty much is, in summary, the 4th evolution of the Industrial Revolution. So you have the different phases of the Industrial Revolution shown here by graphic done by Infosys. Started with mechanization, electrification, automation, and then now we're in the cyber physical space. That's comprised of pretty much 4 general areas, one of which is the Internet of Things. Now, the Internet of Things deals with the networking of people, machine, and things. And when you look at that in an industrial space, it becomes the Industrial Internet of Things, or IIoT. The focus of today's presentation is on the cyber physical system and the pervasive connectivity. Now, in order for you to progress, move from to do big data, advanced analytics, and smart application, it all starts with being able to access the data in the first place. So this goes into the instrumentation, the ability to sense, measure, and monitor the condition of almost everything, right? And then having done that, which is the traditional sense, is having that integrated with the World Wide Web, pretty much, where accessibility is easy. So notice that the key word here is the condition. So condition monitoring is arguably the foundation of IIoT. And what is condition monitoring? Most of us already know, but I'll go through a basic definition. It's a non-intrusive data-driven technique, which deals with a collection of a measurable parameter. Again, it has to be measurable, that indicates the state of an asset. It informs the need of requisite corrective action to mitigate or prevent the consequences of failure or equipment downtime. And pretty much it's the approach that's taken for condition monitoring is dependent on these 4 general factors. Vibration analysis is preferred technique because of its failure mode coverage and its applicability to diverse machinery, including turbo and rotating machinery especially. Right, so what's the whole point of doing condition monitoring or even having an IIoT platform? Before we can again, get to that global sense of really big data and even instrumentation. The machine needs to be available. So we're talking about the reliability of the machine itself. Now, what is reliability? Just to put things in context, it's the ability of an item to perform a required function under given conditions for a given time interval. Now, in today's manufacturing industrial world, the reliability of an equipment is key, and that reliability is being pushed higher and higher and higher because they need the availability of the equipment. It's all about agility, flexibility, and speed. But for your system to be agile, flexible, and for you to produce or provide service quickly, reliability has to be ensured, and that's a foundation. Now, how do we achieve reliability? There are four main tenets to reliability. A system, and notice I use the term system, not just the asset, has to be designed right, it has to be installed right, operated correctly, and also maintained correctly. And this applies to any system, but of course, we're looking, for example, on rotating machinery here. Let's use an example of a pump, given that's our background, but again, this applies to a compressor, a turbine, it doesn't matter. Some of the design considerations for a pump on a typical rotating machine is your design versus your operating point. Now, if a system is not designed correctly for what you're operating it for, again, like the intended purpose, if you're using it outside the context of its intended purpose, it will be difficult for you to achieve some level of high reliability. And what we've seen in our space is in terms of oversizing, specifying too much margin for your system. It might not be the case for turbo machinery, but for smaller pumps, sometimes for compressors, we see that happening. Right. So again, this is a pump performance curve. We need to understand where our performance for our asset and where that meets the system, so that we have a clear idea of how it should perform. In terms of installation considerations, we're looking at base plate and foundation being properly installed. Piping supports, mechanical season and alignment. Again, this applies to any rotating asset. If you can have the correct design and selection is included in design, or the application is included in design, but when it goes into the field, if it's not installed properly, then again, you're creating yourself a potential nightmare situation where yes, you had the correct design, yes, you had the correct selection, but installation was not done properly. And then on the next bit, we have operations. So now for a lot of facilities, the team installing is completely different from the team operating. And the installers, sometimes we've seen where they cut corners or do things quickly, and then that becomes now a nightmare if that wasn't done properly for the operations, or even if it were installed properly, and the operation becomes an issue where it wasn't commissioned right, or there's certain considerations that didn't go into the system. For example, when I mentioned earlier, if your design doesn't match your system, let's say take this pump curve again, where your pump will always operate at the intersection between your pump curve and your system curve. Now, if for some reason your system was not designed right and you have a restriction in the system, then you're operating actually all the way back here when they think that they might have been operating here, again, because the system does not match what it was intended for, or the pump doesn't match the system. And in this case, it will cause recirculation and possibly, depending on how low it goes, hydraulic instability. All of those contribute to poor reliability in your assets. There's also consideration for where your operating conditions differ from your design conditions in terms of, let's say, viscosity. In the case of viscosity, if a pump was specified for a certain viscosity and you go to a higher viscosity, there is a degrading effect on your performance of your pump and also on the efficiency. So, which is why, again, it's important to be cognizant of all these effects when looking at the reliability of a system. And again, this is the foundation. Unless you have this right, there's not much you can do in terms of extracting useful information in terms of data and putting together an IoT application. So you need to be aware of the failure modes also that your system exhibits. For maintenance, what we've seen, and this is based on history from ABT reliability also, was formerly Shell reliability. Typically, systems are in the reactive and planned preventive. And of course, there'll be maintenance strategies available that says, yes, we're doing a predictive, and we even have best practice proactive. But typically the system that we've seen are between the reactive and planned preventive space, and customers are looking to get into the predictive space still. Again, this varies depending on where in the world you are, but this is typically between Europe or England and what we've seen here in Canada. Right, so the key to this is, again, you might choose to do anything along this line depending on the criticality of your asset. You might choose to do nothing if it's something that's not worthwhile in terms of creating any strategy towards doing anything about it. You want it to run to failure. Also, you might go into the proactive case where it's all designed in, so defect elimination from the design phase. Now, a lot of us have seen this before in terms of the PF curve, but again, I have to use it to put things in context. Where vibration is concerned and condition monitoring. You have the design space, again, being designed right, installation in terms of precision and maintenance, but when you come to the operating space, there are different technologies that is applicable to detecting faults. And let's take, for example, vibration as you have ultrasound. The PF curve looks at the condition and as time progresses. And in this case, we're looking at the functional failure or your progression to functional failure. This shows that different assets are able to detect your onset of a failure or detect the initial onset of the failure and give you some lead time towards correction before you get to a functional failure. And if some form of correction is not done after you get to functional failure, which is the asset losing its intended purpose or not being able to perform a certain function, then you move on to a catastrophic failure. Now, we also need to understand that different techniques give you different lead time to indicating that functional failure. For vibration, you can detect failures or the onset of a failure, or give you a lead time towards a functional failure 1 to 9 months in advance. Again, which is why vibration is usually preferred because of this indication. So you will have 1 to 9 months to do some form of corrective work before you lose function in your system. All right. Another thing that we need to take into consideration, let's drill closer to vibration, is that protection does not equal monitoring. So a lot of systems out there have fixed vibration probes, usually some from a metric sensor, typically, and that system gives the operator a trend in a control room, and that trend is usually an overall RMS level. That trends over time, and if it goes beyond a certain alarm point, warning point, you get an alarm. If it goes beyond the red point, you get a shutdown. Now, again, to put this in context, typically for your protection systems, that sensor looks between 10 and 1,000 hertz in the spectrum, because some people might say, why do we need additional monitoring if we already have a protection system on it? Again, typically. However, this view of what's happening with these protection systems looks at your general faults, your unbalance, your misalignment, your foundation issues. It's not looking higher in your spectrum where you can see a lot more that's happening, and even higher still. So this goes up to 2,000 or higher hertz depending on the system that you have. Now, when doing monitoring, again, a lot of these protection systems, you don't have access to the raw data. In this case, this was a bearing and gear fill on a small gear drive unit. So in monitoring, your analyst will look beyond what the information that's available to an operator. That's a business case as to why you would want a monitoring system that has more capabilities. And now that we're into the monitoring system, in terms of AVT reliability, Westpower, and Machine Sentry. Machine Sentry is the AVT reliability IoT platform. The slogan of it is cost less, does more, and it's that simple, really. AVT reliability, formerly Shell Reliability, has been around for more than 20 years now. They've been developing this platform, and it's pretty much in a mature state. And they're based in England, and they partnered with Westpower to offer the products and services here in Canada through the Westpower Reliability Group. Now, what is Machine Sentry? It is, as I say, an IoT platform that has a suite of products. It handles, it's based on condition monitoring. So it handles vibration, hot oil analysis, thermography, visual inspection, and process parameter trending, all in a single platform. Easy to use user platform. You can also use for basic action management and maintenance management, and all the diagnosis is done within the platform itself, and I'll show you that in the case study.
Okay, Adrian, I'm going to put a poll up right now
Sure.
and just see what people think of what's the most critical. So what do you think is the most critical parameter to monitor with cloud-based hardware and software? The poll is live, so feel free to click which one you feel is the most critical, the most important one. Okay, so good amount of people have voted. Seem to have slowed down, so I'm just going to give this another 5 seconds and then we'll shut off the voting and see what people think. Okay, here we go. So 9% have said temperature is the most critical, 50% vibration. Nobody thinks oil analysis is the most critical, but obviously I'm sure we know that it does have its place. Visual, audible inspection, and then 38% say all equally important. So do you have anything to add to that, Adrian, or to comment on that?
Sure. And it's interesting, the spread of responses, and it all again depends on your system, and it depends on what you're looking at. If you're looking at defect prevention or defect identification, then temperature, which is typically used because it's easy to apply temperature, might not be the most important one. You might want to consider vibration. However, temperature can be used as a leading indicator for an impending problem. So it's an interesting question where there's no right or wrong answer. It really depends on the context in which the system operates and that you're using the technology.
Yeah, I think in a lot of cases you could say that visual and audible is sometimes the most important, because your operations people, they know what it's supposed to sound like, they know what it's supposed to look like, and sometimes you can spot something right away that's out of place, and so you may not necessarily need next level diagnosis, right, to find a problem.
That's true, and you'll see in the case study where that's pretty much the case of it, where your equipment experts are your operations because they're around it day in, day out. So we'll see it as we go along.
But I think what I've also read too is that vibration is not something that you can see or hear either. So I think I've also seen that particular thing is maybe the most important thing to predict any type of failure coming on. But anyways, so there's a couple more questions. I guess we were supposed to put these on earlier on, but we might as well address them now while it people's attention. So we're going to launch another poll here. How familiar are you with the term Industry 4.0 and its relation to asset management? Heard it once before? I have a basic understanding. I have a very good understanding, or my middle name is Industry 4.0. Cruel parents. Okay. About half of our attendees have voted so far. It's going up. May I'll give this another 10 seconds perhaps. There's some good activity going on. And 5, 4, 3, 2, 1. Okay, so heard it once before, 50%. So I have a basic understanding, is 33%. Now I have a very good understanding, 13%, and a lot of honest people, it's only 3% that are truly considering themselves experts in it. So half, and I think that that says a lot as far as general understanding of what this means, because I think we see it a lot out there. At least I see a lot of stuff written about it, and I think it can be confusing, right? So I guess it depends on how it pertains to you and what industry you're in. So do we want to run one more? This is just a quick little fun fact, I guess, about the origination of the term Industry 4.0. And these were questions from Jared, so I don't know if he's got the right answer for this, hopefully. But anyways, we'll launch this one and see what people think. So, where was the term Industry 4.0 originated? USA, Canada, Germany, China, and I added this one in space. And I'm going to make my own guess because I have no idea. Do you know the right answer to this, Adrian?
Yes, I do.
Oh, you do? Okay, good.
He taught me, so
Oh, okay.
yeah, he helped me with the answer for this one. So.
Okay. So it looks like, well, I'm just going to stop the voting in about 5 seconds, and then we'll do our tally. Okay. 18% say USA, 18% equally Canada, over half, 54% say Germany. Nobody believes in China, I guess, but in space is 11%. So, well, so what's the right answer?
Jared, you taking it?
The correct answer is Germany.
Germany.
So
Okay.
good guess if you're guessing, or maybe we've got some knowledgeable people, which I think we do in the audience. So that's good.
Yeah, I took a total guess myself. Okay. Anyway, so now carry on, Adrian. Now we're getting into, the more specific. I think it was necessary to go through the background because not everybody's starting from the right place or the same place as understanding goes. So, the introduction into, why condition monitoring is important and how that plays a part. And so here, really, we're going to get right into the meat and potatoes of, the systems that you guys have been working with, and really how to apply that. So, make sure you guys stick around. We're going to do some interactive, demonstrations of the app itself, and you're going to be able to see, exactly, what you can get and what it can do for you. So, yeah, stick around. Keep going.
All right. So most of us have seen hardware before in terms of condition monitoring. You have 3 different levels for the machine-centric suite of system, which is not dissimilar to what's typically out there. The first level for lower criticality assets typically is your route-based sensor. It's a handheld sensor that's Bluetooth enabled. I will demonstrate how that works later. So this, you go from machine to machine. It has a magnet, 2-pole magnet for curved surfaces, and takes temperature and vibration. It works with a tablet, and you move from one machine to the next. Now the next level up is the machine-centric fixed sensor, where you leave the sensor in place on the machine. It stays there permanently. Can either be magnet or stud mounted. Now this sensor captures the data itself, stores it internal, and there are 2 ways of accessing the data. Either an operator or a technician walks past with a tablet, downloads the data, so it can collect data, let's say once every hour, indefinitely, and then someone walks past with a tablet, or there's access where it goes through a gateway that automatically uploads the data to a cloud, and I'll show you how that works also. This is suitable for confined spaces, hard to reach areas, or infrequently running assets where you pretty much never catch it on a route-based monitoring program. So you leave this on the machine and it actually wakes when the machine starts up. The next level up for your even more critical systems and our turbo machinery audience will be interested in this is the machine-centric online system. Now the sensors are wired and uses any sensor from the machine into the unit itself. The unit is LTE enabled, so there's no wire leaving the system, and it pretty much transmits the data, live data, from the machine to the cloud. It's a self-contained, really small unit that, if we have a chance in the end, I'll show you what it looks like. And this itself is tied to a cloud system that you can access the data from anywhere in the world, and I'll show you a demonstration of that afterwards. Now, how it all works, as I said, there are 3 levels to the system: machine-centric mobile, machine-centric fixed, and machine-centric online. So for the fixed system, as I said, the sensor is Bluetooth. So it goes from Bluetooth to a tablet, and then the tablet beams the data via Wi-Fi, or uploads data via Wi-Fi to the machine-centric cloud. And the machine-centric cloud has an automatic diagnostic assistant, or its AI, which is constantly developing, it's constantly learning different fault patterns and failure patterns. Now, this cloud platform can be linked back to a customer's CMMS or some form of system. So again, if it's being exported for big data processing or advanced analytics, it's all in the cloud. And also the cloud platform allows the flexibility of getting an external analyst, for example, an external expert looking at the data. So it's a secured cloud platform. The fixed works just the same as the mobile, as I said. It stays on the machine. I can either access information from the fixed via a tablet or from a machine-centric gateway. The gateway is permanently installed in the field. So in this case, you do not need an operator at all. The sensor collects the data, and again, via long-range Bluetooth goes to the gateway, and the gateway automatically uploads. The gateway is LTE enabled also. It automatic uploads to the cloud, or you can use a Wi-Fi router to access information through the gateway. And as I said earlier, for the online system, it goes directly to the cloud from the wired sensor. This is for customers who do not have a communication infrastructure. This is pretty much plug and play, provide power to the box, wire your sensor, and then you have access directly to the cloud. So pretty straightforward. So lower criticality, mid criticality, highest criticality, or for turbo machinery. Now, let's start with where to start in terms of our case study. Now, there are different customers might say, hey, where do I start? How do you start a system? There are different levels available for starting. In the case study that I'm going to say, we did a build and discover where we went in and worked with the customer to the point where they're able now, they're doing their own data collection, and Westpower supports with our RDC, our remote diagnostic center. And then as the program goes along, we will be training them now optionally so that they're able to do the data collection and analysis on their own. Again, it's an a la carte where you can choose where you want to start and how to start. So in jump into the case study. Now, we chose a municipality as a case study as opposed to an oil and gas customer that we have, because we have several customers in oil and gas or even in the power generation or power utility. But we chose a municipality because if anyone knows anything about municipalities, is that the budget is very constrained, and yet still, in this case, they had an issue with one of 4 wastewater transfer pumps. These are 600 horsepower transfer pumps, and it's extremely critical to the town. If these pumps go down, all 4, pretty much they're unable to transfer wastewater to a processing station, which is in a different pretty much city. And they had an issue. They called us in to look at it. We did the vibration analysis on these pumps and realized that, okay, it's a bearing issue. We recommended to them replace the bearings, and also a recommendation was made based on the criticality of these pumps that they should have some form of monitoring program on these pumps instead of waiting to figure out meaning in a reactive sense, whereas you can have a simple implementation on these pumps and then know what's happening afterwards. So in the case study, so in terms of who, as I said, a municipality of about 30,000 people, very constrained budget. They decided that yes, we're interested in a condition monitoring program, so they chose 50 critical pumps, and these are at multiple pump stations across the town. So in the design of the system, we worked collaboratively with them, and it's a monthly data collection by the operators themselves. And again, these are operators who previously knew nothing about vibration analysis. So we went in, trained them on how to do the data collection, and then Westpower does quarterly analysis through our RDC or remote diagnostic center. So and why the aim and what we've been able to achieve over the past year and a half is improve system availability. So for municipalities, it's all about risk. You need their station available. Resource leveling, because again, they didn't have the internal expertise to do the analysis. So they're able to leverage a cloud platform, our IoT system, to get that resourcing or expertise that's needed. How? And that was through the machine-centric mobile system. So I'm going to jump now to the online platform to show you how this works.
I think that's quite a good example. I think, you know, like you were saying, you know, it seems like you've got all the bases covered with different options of how to monitor, because not all the equipment is the same, right? So depending on the criticality, it seems like you've got all the bases covered for, you know, how to monitor, what kind of level of intervention and resources to apply to this. And so the other interesting thing too is that, you know, for somebody that's unsophisticated or, you know, not tech knowledgeable or even very computer illiterate, you know, can really utilize this system quite easily and get useful information out of it. So anyways, it seems like it's really working quite well.
Yep. So it's a secure web platform that you can grant access to at different levels. So access can be for a data collector or site manager or site engineer or site builder. There's a quick dashboard, and of course we're going to show you a demo extract, which is confidential information. So we extracted a demo section of the customer's site, scrub the customer information because it's confidential. And so how the platform works, they have their KPI in terms of metrics, just asset health and schedule compliance. Asset health looks at actions that are raised by the operators on their tablets themselves, and you'll see that shortly. Schedule compliance, each point that's monitored, in this case, there are visual inspection or PM checks, vibration checks, and temperature checks done through the mobile system, and it tracks if they're on schedule or not. Right? AVT pushes updates to the system that you can get notification of right here, regular release, and that's very important for any IoT platform. Ensure that there's a development plan for that platform if you're thinking of doing an IoT platform, and that there are regular updates, because these updates ensure the stability of the system and the security of the system, just like your phone. So if you're an iPhone or Android user, you realize there are regular updates pushed to your system. So the site hierarchy, in this case, it's on the Westpower because I said it's a demo. So that pumping question, so the site hierarchy is set up as any ERP system would be set up SAP or maximum. We have organization, a site, and a zone, an area, and then the asset itself. So that case study was for booster pump number 4. Now, the asset is comprised of 2 components, electric motor and the pump. So at every level, as you drill down, you see that the information here changes. So this is what the pump looks like. There's a pump itself. It's a vertical 2-vein wastewater transfer pump, 600 horsepower, and then you have your serial information for your system. Now, the system tracks the condition in this window by color coding. So green means everything is good, yellow means warning, and red means alarm, blue means no data collected. And again, this is actual data that has been, the customer information has been scrubbed. So we see here, we're right off the bat, the non-driving, there's an issue. And this was collected, last one collected the 21st of the 5th. They're yet to do their June collections. And you can see since implementation, after we repair that pump, they've been running low, but something has happened. Now, previously, they wouldn't have seen this. This would have just gone unnoticed or unattended. They would have just probably excessive vibration in the building and not known what it is. But because of their data collection, and the quarterly analysis, we're able to catch this as being attended to. But the platform allows you to do your analysis directly from here. So you can bring up your spectrum and your acceleration, time waveform. Obviously, I won't get into the actual details of how the analysis is done, but the platform allows the flexibility of everything is done from within the platform itself. And that's the wastewater. They've also implemented this is just a subset of all the pumps. So in this case, you see again, zone 6, there's an issue. Zone 1 is in green. The fire booster pump is in red. The gearbox. And the platform also allows for the management of oil samples. So this is actually an oil sample that was done last year, an ad hoc sample that we can take sample from any lab really, and it's imported automatically into the system, and it's trend. It starts a trend of all the parameters. The system being flexible also allows for automatic report generation. So again, they have access to all this information, so there's complete visibility to them. And if they need to do reporting, they can, but really all the reporting is done remotely by Westpower, where they can track any parameter that is put up. Like the system, the flexibility that an IoT platform offers is, like, as I say, it's quick, responsive reporting and defect identification, and pretty much bringing some form of resolution to the problem.
So Adrian, I'm just curious now, you know, from the elevation from healthy to, you know, warning, when do the end users get a notification that something's changing? You know, did you get a notification when it goes to yellow and then another one at red? You know, is that an email, I guess, it gets sent out?
Yes, so you can set the limits in. For the machine-centric mobile system, the automatic diagnostic assistant actually sends you as soon as it touches yellow. It will send an email notification that says this asset is in alarm. Again, all the limits that you saw there, let me go back to here. All the limits, these yellow and red lines, everything is adjustable depending on the access that you have for the system. So you can set different limits as you need. And once you touch one of those limits, it sends a notification. And again, this is for this system is not live monitoring. And you would say, why not use a the live system for such a critical pump? But again, there is a cost versus impact consideration, where depending on your budget constraints, it's better to have a system that works than to have the most sophisticated one that you might not be able to afford. All right, Andrew, I'm going to jump on the mobile platform. So now that we've seen this, to show what the operators actually do on a monthly basis when they're doing their rounds.
Okay, Adrian, I'll change that over for you.
Was that Jared?
I was just going to say the one point that we should clarify too, with those parameters, there is, if you want to explain how they're preset, but you know, we can also move them up or down based on customer preference as well, right?
Yep. So yeah, initially it's set depending on if it's a turbine. You have ISO, if it's a pump, ISO 10816-3 for motors, -7 for pumps. If it's a wastewater pump, you might want to use a HI limit, Hydraulic Institute, or something from the manufacturer, OEM limits again, or something the customer prefers, and we'll guide customers on what to use. If it's a screw compressor, let's say a twin screw compressor, might use VDI 3136, which is a German standard. Again, that's where the expertise comes in. Anyone who's setting up a program for you, they need to understand a wide range of rotating equipment, not just pumps, and understand the fundamentals of how vibration and how condition monitoring works.
Perfect.
So
good.
We're going to jump to the mobile platform. Andrew, can you hand it over to the tablet?
Okay, I thought it was. Okay, here. Well, let's see. So what happened there?
So now it's on the main presentation. Yep.
Here we go. How's that?
Nope, it's not coming up. What are you guys seeing now? Are you seeing still the main presentation?
No, it's just the waiting screen, I guess, for everybody.
Okay. Not sure what's happening here. Try again to give access to Westpower reliability.
Okay, I'm going to switch back to yours and then go back to Westpower reliability again. Here we go. Sorry, everyone, this worked before we actually went live. I don't know what's happening now.
Nope. All right, so I'll just, no, it's not coming up.
Okay.
I'll jump to
Show the back
system. I won't hold up much time with that. I'll jump to the live system. Okay, all right, I've got it.
Oh, we do. Okay. So
All
I'm
right,
going
so
to.
now you can give access.
Okay.
All right, perfect. All right, so now I'm going to show you what the.
Okay, looks good. Oh, it disappeared again.
Okay, that's coming up right now.
I wish I had some singing or dancing ability. I could keep people entertained, but that's not me.
All right, perfect. Let me know if you're seeing it.
Yep, we've got that now.
All right, so how does the system work? The machine-centric system, the basic one, the machine-centric mobile, which is what the municipality uses, it's an app. It's an Android-based app, and the login for the app is the same login that we did for the online system. Now, when using the app, the user interface is just the same as what you saw online. So there's a site hierarchy synchronization. So on their monthly rounds, they would go to sync, and they will sync before they go into the field. So you see demo wastewater site, you select which site you're going to sync, and then you click on the sync button. It takes less than a minute. I won't do it now in the interest of time, but it's actually less than a minute. So they will sync before they go out. And again, the sync is done via Wi-Fi. So they're inside the office, connected to the Wi-Fi, office Wi-Fi, run a sync. When that's completed, then the hierarchy looks the same as what you just saw. So organization Westpower, wastewater zone, wastewater booster, and pump number 4. The flexibility of the system being IoT, you can make any change to the system. You don't need to be connected to Wi-Fi to do your rounds. So you connect, sync, and you go out into the field. And you take your sensor with you. I'm not sure if you're seeing me via the webcam, but the sensor, the machine-centric mobile sensor, you take with you. Then you go mobile sensor. The system searches for different sensors. And in this case, I have several around me because I have some fixed sensors, 84, 85, 82. And I also have the mobile sensor, which is 009X. You select that one. When it's all paired, it will say it is paired. And the sensor will flash. You're not seeing that now, but if it flashes from one blue light, there's a LED indicator on the sensor. So now I'm ready to go. And again, this you can do without Wi-Fi. Wi-Fi is just for the sync. So you can be in the field and do your pairing. Then I need to go and collect my data. So let's say they're doing a round on all the pumps. They're doing a round on all the pumps. They go take, they can start and, sorry, so the route is based on the order of how things are arranged. In this case, you see pump number 7, but like, nope, I want to start pump number 4 in my round. So if you want to make changes, all the changes can be done offline where I can change my round. So let's do pump number 7 last, details, and I'll save that. And you see it's reordered. Then I want to go take. Then our system is programmed to do your visual inspection first, just like your PM checks, and this can be customized. So for them, they use the basic PM checks when they're doing their runs. So they go capture. Let's say there's dirt debris on the pump. You click that, as I said, N for normal, W for warning, A for alarm. They want to make a note of that. Let's say, rats. But a picture is worth 1,000 words. So instead of making a note, I want to take a picture of what's happening here. So you can see my camera right now, and you can see that's what the sensor looks like. And I've mounted it to my rig. And thankfully, I'm able to take my rig home. And that's the online system in the background. So capture that. That's automatically saved at the asset location, so you don't have to do anything again. So the agility it affords. And I go save. In their case, they capture the VFD output also manually, but I'm going to skip that to the vibration section. Now, for vibration, you can do triaxial or single axis. For triaxial, you set the sensor how it looks on the actual equipment. So in this case, it's either this one. Let's use this one. I could choose to go single axis, but you want triaxial. Then you click capture. So the system, I'm going to turn this on, so capture something.
Hey, Adrian, I just want to let you know that we've got 5 minutes until the conclusion. Keep going. Go ahead.
Yep. So it captured something in the last half because I switched it on afterwards. So it'd be non-driving horizontal review, non-driving vertical review, non-driving axial. And if you want, it will, because I only captured when I started taking data after I switched on the equipment, or took the data before. You can look at your time waveform or the spectrum itself. You save that. I'm just going to close and show you what the sync looks like. So now they're finished their round, and I'm going to run a sync. Now, as I said, the sync takes less than a minute. And while that's syncing, I'm going to move from the mobile platform and just switch the share back to the online system. So even while it's running, it will prompt you, but the information is already available online.
So we had one question about the sensors, about temperature limits, and being in northern Canada,
Yep.
That's usually a valid question. So I guess depending on which sensors we're talking about, but maybe you can just address that quickly.
Sure. The sensor is rated for -20. Now, the thing with any battery system, of course, temperatures in Canada drop to -40. If it's a mobile, it's -20. The fixed system can go down to -40. At about -20, you'll get about 5-year life from the fixed sensors. And at -40, then that life, because of the battery, which is replaceable, goes on to about 2 to 3 years. So for temperature purposes, for the fix, it will still work outdoors in our cold temperatures, but you just have a reduced or diminished battery life, which if you're getting 2 years from a fixed sensor, that's still enough. And as the system prompts. Now, if for the mobile, typically it's not left outside long enough for it to get to -40. So at -20, anything below -20, then it's a limitation of the mobile sensor. As again, it shouldn't be left outside for it to cool down to -40 if you're under those conditions. It will work fine. We've used it in Saskatchewan, which gets really, really cool. I personally use it in -30, and it worked perfectly fine.
Yeah.
All right, so we're going to jump to the online platform because I know I'm running out of time. So jump me back over to my main screen, Andrew.
Oh, I apologize, that's my bad there. Okay.
So you saw the sync was completed, and are you seeing my main screen? Yes, you are. So I'm going to jump online. So refresh that.
Okay, so this is you logging in to the web.
So I'm already into the web. So we collected data on booster pump number 4, the visual inspection. So I said rats. So you see where it has right here that I made a note rats, and I took a picture. And that's a picture right there that I took of the system. And this was not there previously. I don't know if you would have noticed. This was just taken. There's a timestamp there. The timestamp is in British Standard Time, which is why I say 1955. It's a world platform. And again, you can raise an action either from the tablet or from here. What do you want to do about it? Right here, I could say, raise that action, and then that action gets a unique action number, and that action can be exported into your CMMS either manually or directly through an API link from the cloud. And I think I have 1 minute left. And in a nutshell, that's what we do on a monthly basis. So when they collect the data, we then go in, do the analysis. So again, this was just taken. I would go in, look at what's happening. You saw that time waveform. Again, the only reason why I didn't collect at the first point because I started collecting before switching on my little rig there, as you would have seen a complete waveform. And I would we would affix our analysis to this and send them a report. So they would get a reliability service report of actions, what to do about actions, and on what recommendations for correction. So I'm going to jump back to the presentation window. Now, considerations in closing, in any IoT system, what strategy fits my operation? even though this was a condition monitoring program, it's a hybrid total product TPM program where, because we have the operators actually doing the maintenance action, right? Again, as we said earlier, they're the ones who are closest to the equipment. You know, when is the most suitable time to implement? The train is moving right now in terms of agility and flexibility for IoT platforms, and it's all based on what's best for your business case. Where to start? We've had customers start with pilot projects or in a phased implementation. We would recommend a pilot project so you can select a control space to do a test, which actually has real problems to see if it provides any results. We had a oil and gas company who actually did a test for 6 months, and we were able to realize $500,000 in defect identification that would have probably gone unnoticed. You want to know how will the platform develop and is it secure? Who will provide system support and support for problem solving? So at Westpower, we provide a full service to this municipality where we are contracted to support them with the analysis and also do the remedy implementation. Some people might say, why would they let the same company analyze and implement a solution? Well, the thing with rotating equipment, if it's not implemented properly or the solution is not done properly, you'll see it can't hide. And why do you need an IoT condition monitoring program? You don't need it, but if you're interested in agility, agility is all about being able to quickly respond and flexibility, being able to quickly change in today's volatile market. Agility and flexibility are the two main buzzwords, and that's the whole premise of Industry 4.0 and IoT, really. Industry 4.0 is all about agility and flexibility. It's no longer just efficiency, productivity, and also having a cloud platform, there's that scalability of customers being able to jump from one to next. And the last thing I'll show here is for our turbo machinery guys, online system. I'm going to stop sharing for a second. And this is one direction that even our municipality can move to, where if as a town grows and they decide they want to jump to a more sophisticated system where they're doing live monitoring, right? This is our Machine Century online T-Wave Brain platform. Again, secure platform, and this demo is set up. Give me a second. Okay. All right, there you go. All right, this system is set up. It's a 12-channel system that's set up on actually a demo turbine in Spain. It's live data. It's a secure cloud platform, and you can again grant access to any party, and you can limit the access rights. This system allows for all the advanced processes that you would do on a turbo machinery. So you have your polar plots, orbit plots, your waterfall. Everything is done in a self-contained, a really small self-contained unit. You might have noticed that in my picture here, that this is the self-contained Machine Century Online. This is the mobile case. It's really small, a really small footprint. This has its own processor, 12 channels, communication protocols via Modbus if you want to go back to a SCADA system or some form of supervisor system. And again, as I said, there are lots of access and lots of ways in which customers, depending on what level you're interested in, can use IIoT. Now, thank you so much for your time. I think I'm out of time, so this is where I'll stop here, Andrew.
Well, thank you. You know, I think it's unfortunate that we didn't have enough time to really go through this last portion here, because I think that's really a big game changer where, you know, you're getting a lot more value, you know, with a very low cost. I mean, what you can get information-wise, protection and monitoring of, you know, critical turbo machinery like steam turbine, gas turbine generators. You know, it's incredible. Normally you'd spend a lot more money on that, and everything's available at your fingertips at a really affordable budget. So definitely seems like industry is moving very quickly. So I think it's great for, you know, to have people like yourself, you know, tell us what's going on and you know, what new developments are out there, and what direction the industry is going in general. And like you can see from this slide here, you've got the bases covered. Depending on the situation, depending on the criticality, you've got a solution for it. So fabulous. So thanks very much, Jared and Adrian. I guess we're not going to do any Q&A right now, but there is contact info. You can always send emails or respond back after. Everybody's going to get a follow-up email with a recording of this webinar as well. So you can always review this at a future time or forward that on. So thank you very much. And if you guys have any closing words, feel free.
Yeah. Do you want to go? Okay, I was just going to say, yeah, obviously you can see that it's tough to pack all that into an hour, hence why, feel free to reach out to us for more information, a better overview on that T-Wave, MSM, you name it, because, really it does justice when you've got it on a site demo and we can bring it in there, let you touch it, feel it, see it. Is really the best way to understand it, although this does give you a good insight. So by all means, reach out to us. And if I could say one key thing that would be a key takeaway and where the Industry 4.0 is going with things in ABT would be organizational transparency. So the guy on site taking the readings, like you saw how fast it was, head office can see that within 30 seconds. So everyone's on the same page, which is key. And time saved when we're taking these readings is crucial, right? We would only be wasting time, 5 minutes uploading each little data point. This is quick, fast, transparent, and bodes well for the way that things are moving. So it's good. So thank you very much.
Thank you. And just in closing, Andrew, don't be intimidated. Thanks for your time, firstly. Don't be intimidated by Industry 4.0. But just know that with the permeation of cloud technology and IoT devices, that it's affordable. Systems, actually, they do work and you do see results for them. And as you can see, again, we chose a municipality just to show you how flexible in terms of options that are available. And that's the beauty of really Industry 4.0. And now, in that cloud space, the opportunities for them, for that town to grow and to do something with that data is endless, because all that data is readily available, where previously they wouldn't have that data available, and it's all stored. It's their data secured in our cloud space. So again, thank you for your time. Thank you, Andrew, and thanks to the RATS organization.
Okay, thanks everybody.
Bye-bye.
Have a great day.